Let's find the shear center of this parallel flange channel. And recall that the shear center is the point where a shear force passes through that doesn't cause a section to twist. So because the flanges produce a couple as follows, due to their force resultants, then our guess is that the shear center is at some distance E to the left of the section. So the moment produced by the resultant force in the web counteracts that from the flange. Now to find the resultant force in a flange, we'll use calculus. So if we have some element of width dx, then the complementary shear stress multiplied by the area on which it's acting, so this differential area has the thickness of the flange by dx. Now remember that tau by T is the shear flow, so that will be VQ on I. So what we have is VQ on I dx, and we integrate this over the length of that flange, so from 0 to 100 millimeters, and that gives us the resultant force in the flange. Now as we go from the left to the right of the section, taking an area of the flange that's at some distance x from the edge, then Q is y bar dash of that area by a dash. So as we can see, the centroid of this area, measured from the centroid of the section, can be calculated using geometry. So that will be the height of the section on 2, which is that distance, and then minus the thickness of the flange on 2. And that's multiplied by the area A dash, which is the thickness of the flange by x. So if you calculate this out, you'd get 3.2 by 10 to the 3 x. And similarly, you can calculate Ixx of the section, and I'll leave it for you to do that using the parallel axes theorem. So that would give you 1.5 by 10 to the 8 millimeters to the 4. And the dimensions of these types of sections are typically given in millimeters. So in a similar way, Q would have units of millimeter cubed. And now if you substitute these values in this integral, so we're integrating from 0 to 100 of the shear force by Q on the second moment of area. And this is integrated over x. So if we divide these constants and take them out of the integral, we get 2.1 by 10 to the negative 5. And evaluating the integral, we have x squared on 2, evaluated from 0 to 100. So this gives 0.11 V. Now if we take a sum of moments about this point, to eliminate the moment produced by the resultant force in the web, so we have 0.11 V multiplied by the moment arm, which is the depth of the section, minus the thickness of the flange. So note that the moment arm for this couple is measured from the middle of each flange. And then we have a counterclockwise moment produced by the shear force V by the eccentricity, and that's equal to 0. So the V's cancel, and we obtain an eccentricity of around 39 millimeters. Please subscribe, like and comment to help me reach more students.